Okay.
2.1 problem 4 says James.
2.1 problem 4. Complex numbers. Ah, yes, that's a good one, actually. Um, so let's go 1 plus 3 times I.
I know, we got that one. No, 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 no. James messed up. I said it was 2.2. It's 2.2.
2. Okay, 2 point. Okay, complex. This one's easy. 2.2 problem what?
Let me check real quick. Also, I didn't know how to solve for eggs. You have to set eggs.
Like I said, tell me the example. Tell me the problem number.
3 raised to the x equals 17.
How do you solve for
Okay, I need one person to talk at a time because I can't hear everybody all at once.
3 raised to the x equals 17. We need to solve for x.
Okay, 3 raised to the x equals 17. Okay. And of course, this won't work. You can't solve it that way. What is this chapter? Is this symbolic? What section are you in for this? 2.1. Okay. 2.1, number 2. Solve for solution is x equals log 17 divided by log 3. So they're giving you a hint how to solve it.
Oh, I thought you just put that in and then it would.
No, it can, but it's a more complex topic. You can solve for x. It's more complex. You can use, but you can. This is actually using Matlab like a calculator. Please keep it whisper if you got to talk to other people, because it's hard to hear too many people all at once. So this problem 2.1 and problem 2, it is using Matlab like a calculator. So you can go x equals, I believe, now, I think ln doesn't work in MATLAB. So let's do a little help.
Log is natural log, and log 10 is the base 10 log.
Perfect. That's right. To get natural log, you got to use log is natural log. It's not ln. This is log base 10. This is log base 2. And there's here's exponential function. And I don't know why e isn't a built-in number in MATLAB. You got to go exp1 to get get e. Yes.
Also, on the first problem.
Let's finish this one up. Okay. 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 So to solve 2.1.2, we got to get a little background on how logarithms work in MATLAB. So now we can do it. Log of 17 divided by log of 3. Oops. I hit caps. I hit the caps lock. Good. That's too easy to happen. Okay, here's x. And now we can do 3 raised to the x just for a verification, just to make sure it equals 17. Voila. Okay, that's that done. If it if the problem asks for verification in your homework, do the verification. Okay. Now, we have next problem, next question. Who's?
Oh, that's me. Okay, when it says compare this equation to that equation on 2.1 problem 1 dash 1, I guess, will you just type them both in and the answer you give, like that's how you compare it?
Yeah, yeah.
Okay.
Yeah.
Then I got it.
Is it okay if I put the double equal sign? I put the double equal sign.
That's if it says true, you're great. If it says one for true, you're in great shape. Right. Yeah, you can use a double equal sign, sure.
Double equal sign test if it's.
Yeah. Double equal sign test if it's true or not. 1 for true, 0 for false. So yes, You can use it doubly. Let's go ahead and show the example. Let's see. 2 raised to the 5th power divided by 2 to the 5th minus 1. Equal, equal. And make sure I'm entering this right. 1 minus 1 divided by 2 raised to the 5th power to the negative 1 power, raised to the negative 1 power. The equal, equal sign should test if this is true or not. It's true. True. Answer is 1. 0 is false, 1 is true. Anything else before we move on to anonymous functions? Working with anonymous functions, I think we're ready to move on. Okay, I don't like this technique. I'd rather, in my functions, I'd rather just make a function file. But you can create a function, say, let's see, binom equals @sign. Okay, this is binon. Okay, anyway. So we got a weird name for the function. Function name. Input variable x, and then the function. Now, sometimes you'll use a single apostrophe. This time you won't. So x squared minus 1. So I'm just going to pick a simple function. And now I've defined it. You'll notice it's up here. So now I can just enter 2. 2 squared minus 1 is 3. Four squared minus 1 is 15. So you can use this like a regular function, like you created the file and use it like a regular function. My personal preference is just create the file and make the function. So, but this is available to you. So that is lesson 2.7. Symbolic calculation is probably a little more useful. Well, you can create a function on one line. So if you have something simple, yeah, it can be useful. It's just remembering everything. When you have it in your file list, it's just right there. So, you know, you come up with practices that you prefer versus, you know, other people might have different preferences. It's kind of a preference. You might like this technique and use it a lot. Then you might say, forget it, I'll just create a function file. You know. Okay. Symbolic calculation, though, whereas anonymous functions or handles and all that stuff, we're going to get into that a little later. That might be a matter of preference. Symbolic, though, this is how we can basically get formulas. So there's 2 ways to do symbolic. Oops, how did something move? Okay, that's it. You type in a list of variables you want to be symbolic variables. So this is one way to do it. X just went away, and we created 2 symbolic variables over here. The previous value of x went away, so if I type x here, it'll just say x equals x. It won't give me the old value. You recall? Let's see. There we go. Here's the old value. You write, yeah, you can.
And y equals y also then?
Right. If I just type y all by itself, but the power comes in creating expressions. Z equals square root plus y squared. There we go. So it always uses this formula. And we can use the eval function. Yes. Oh, that's right. There we go. Front light's off. So this is useful with matrices. Let's A, oops, equals, oops. I'm going to do some sims. Sims A11, A12, A21, A22. So this, I'm going to show matrix multiplication. Matrix methods are very important to MATLAB. Everything's a matrix in MATLAB. And I'm also going to go sims x1, x2. Oops, that's xz, x2. There's another way to do sims. You can do x, this is weird, x1 equals sym of, this is another way to declare a variable to be symbolic. MATLAB is tending, MathWorks, the people who are writing MATLAB, they're tending to go to this more. And I don't know if they, this is too convenient though. I don't know if they can ever get rid of this. So I'm going to make a vector x equals x1. So I've just made a symbolic vector, column vector as a matter of fact. And I'm going to make a symbolic matrix. Okay, so now I have my symbolic matrix. The matrix multiplication, now we've talked about this before, about how you multiply matrices. We've never done it symbolically. You'll notice that A11 stands for first element, first row, first column of matrix A. A12, first row, second column. A21, second row, first column. A22, second row, second column. And you can multiply matrices by column vectors. You can't multiply them by row vectors. That's why X is a column vector. So I can do A. Now, this will give me a completely symbolic answer. Matrix A times vector X. And I'll get a completely symbolic vector. So this, you'll notice the first row of X multiplies the first column of A. This is how matrix multiplication works. For those of you not familiar with linear algebra, this is also a good way to demonstrate how symbolic calculation works. I kill two birds with one stone doing this. Second row of X multiplies the second column of A. Column 2, column 1, row 1, row 2. Okay. So this shows matrix multiplication, and it shows symbolic calculation. I'm going to do one more. I'm going to create matrix B. Do I have to put a, no, just I separate it with spaces. You always got to remember whether you're separating by commas or spaces. This one takes spaces. So we're going to do matrix multiplication. So I just set up matrix A. Well, you know what matrix A is from before. Here's matrix B. So I get, I multiply a 2 by 2 matrix times a 2 by 2 matrix. The first column of B, these two variables here, multiplies, here's B11, it multiplies the first, this first column, okay. B11 will multiply A11 and A21. The first row of B multiplies the first column of A. Then you have to add it to the second row of B multiplied by the second column of A. There we go. Second row of B multiplied by the second column. You'll notice how this index is the same in both cases. There. Same thing over here. First column of A multiplies first row of B. So I'm just highlighting the indexes. Those are the same. You'll get to the Einstein summation convention later on, by the way, which will do this. Will exploit this. You don't have to put a summation symbol. You can just assume that you're adding, that when these two are equal, you're going to be adding them up. So we step from 1, then we step to 2. The first, now we go to the second column. The second column of the answer is based on the second column of B. So the second column of B, B12, multiplies the first row of the second column multiplies the first column of A. The second row of the second column of B multiplies the second column of A. And creates, the second column of B creates the second column of the answer. Okay, that's a little bit of linear algebra in a nutshell, probably way too fast. Am I guessing if you've never seen this before? Yeah, it's like drinking out of a fire hose. Using Sims, though, you can start to understand, especially you guys, when you get to matrix methods or linear algebra, when you get to studying it, you can use this. You can take your Matlab program on your laptop and create your symbolic matrices and multiply them and see how everything works. MATLAB does depend a lot. It works based on linear algebra. By the way, let's see. I'm going to create C. B, second row, first column. So this is just the first column of B. I've just created the first column of B. When I multiply A times C, I get the first column of the answer. Too bad this isn't more like Excel where you select cells. It's like text. So C is the first column of B, and so the answer here will be the answer here. The answer here will be the answer here. If I made C the second column of B, I'd get the second column of the answer, and so forth. Okay. Linear algebra, matrix methods in a nutshell. And symbolic, and using symbolics. Import, export. I'm going to talk about, well, let's export A. Okay. XLS write. That's the command to export A. And I'm going to, well, it gives me a hint how to use it. So we can create a file name, my export, and then A. I'm just going to export this symbolic thing. Oops. Input must be numeric. Okay, I cannot write out symbolics. I got to create a numeric.
Like 5.
What's that now?
So it would be like 5 LS.
What if you made a
No. The A has to be a numeric. A cannot be a symbolic. A has to be a numeric. The variable has to be a numeric. So I've used C. I'll create a D. 1, 2, colon 3. Oops. 3, 4. So now I've got a numeric thing. I can use XLS. Oops. I got to get back to here. I can now write this out in an Excel file. And it creates my Excel file. And it's taking a while. There it is. There, my export. So I can open this outside of Matlab. It opens up my Excel file.
So XLS makes it, it makes an XLS doc.
Yes.
So if you put doc right, could you make it a?
No. There's DLM right. In fact, I'll do the help for XLS right. So this is how you get stuff out. There's DLM right. There's also CSV right, and I don't know why this C also doesn't tell us about. DLM is delimited, like a tab delimited file. DLM, delimited. So you can write stuff out, and DLM has a ton of parameters to it. Here's the help for DLM right. And you can do a tab delimited. Let's see. There's an example of a delimiter tab. Examples, delimiter, semicolon. There's a tab delimited file. This is the tab character, and so forth. DLM right can get really complicated. XLS right, you noticed it was really easy. It's writing an Excel file. DLM can get really complicated. You might need that for special applications. CSV is comma separated values. Comma separated values, CSV. Right. And I'm going to do a help on that just to show you guys. It's kind of easy. It's just file name, what matrix do you want to write, and it writes a comma separated value file. Works just like XLS write, except comma separated values. DLM has lots and lots of options. You can also use the basic fprint, file print. If you've ever worked with BASIC, you've got some of those things going on. The complication just gets higher and higher. DLM write is kind of complicated. Fprint is even more complicated. Probably you guys will be sticking with either CSV or XLS. Yes.
So how can you ever transport formulas that it has to be a value?
You can create a text out of it. We'll get to strings later on. We're gonna show you how to work with strings later on. And there's a couple other types of data structures called cell arrays and structures that right now we can only write numbers. There are ways to write text. So it can be done. Let's go to our file, and I'm going to insert a row. I'm going to do something new with it, and I'm going to say widgets, okay, Spacely sprockets, and Cogswell cogs. Okay. So I've got some header files here. I'm going to save it. Now I'm going to try to import it. And now the import has a GUI. You'll notice I hit the GUI. I'm going to close the import window and just go over that again. It has a GUI button. The writing stuff, exporting does not have a GUI button. Import does. Just click the button, double click the file you want to import. Matlab takes its best guess as to what kind of file it wants to be. And it's going to create two column vectors. This will be the name of the one, and this will be the name of the other. So for this import, the blue highlight tells you the data it's going to import, and then it gives you names. You can change the names, by the way. These are editable areas up here. So you can change things around, or you can import it as a matrix. If you import it as a matrix, this is the name. These go away. Spacely sprockets and Cogswell cogs go away if you import it as a matrix. So you get this is the name in the matrix, and then you'll get these numbers as the matrix. A cell array is a different kind of thing that you get everything with a cell array. So you can select, you'll get the headings with a cell array. Cell array is like each cell of a cell spreadsheet becomes an element in a cell array. We will get to how to use cell arrays later. So we're going to learn all about this cell array at a later date. But the default, you'll notice that it went right there for the default. The yellow things, I selected the yellow things when I was talking about the cell arrays. And the yellow things are saying, we can't import that. MATLAB's not going to import that if we try to import vectors. So select what you want to import, and then hit import. Import the data. You can import, okay, these were imported. And now they exist. Let's see, Spacely sprockets and Cogswell cogs. There's Spacely sprocket, there's Cogswell cogs, and here's Spacely sprockets. Okay. As you can tell, yes, you can use them like a vector. I can do, now, I don't know if I want to write, I probably want to rename it. Let's rename it. We can rename it here too. There. Come on, rename. Okay. There we go. Cog and space. Oops, doesn't like what I'm doing. So I'm going to do just dot star, multiply them together. The first element of the first elements are multiplied together, the second elements are multiplied together. So now they become just regular vectors. Yes? Let's remove the dot. We talked about the dot. Guys, keep it down, please. We still have some questions on the floor, so whisper, please, if you got to talk. If I don't use the dot, this is what happens. Let's see. They're both, are they both row vectors? No, they're both column vectors. So it'll make COG will become, COG apostrophe will become a row vector. So we're going to multiply a column times a row. And what that'll do is it gives me an outer product, an outer matrix product. It gives you a matrix. If I do this will give me an inner product, a dot product. You guys are working with that in university physics. How many of you are familiar with the dot product, the inner product? I see a lot of people. This is the force times distance times the cosine of the angle between them. That's what this gives us between these two vectors. Here's space prime. It's a row vector. A row vector times a column vector gives us a single number. Okay, what the dot does right here it takes 1 times 2 and puts it there. It takes 3 times 4 and puts it there. So the period up here, period times, is just does element by element. So we have A and B still sitting here. Oh, let's do that. A dot star B. So A and B, I believe, are still, yeah. So it takes the first, it takes element 1 of A multiplies by element 1 of 2. You'll notice the indexes. So this is row 1, column 2 of A, row 1, column 2 of B, row 2, column 1 of A, row 2, column 1 of B, row 2, column 2 of A, row 2, column 2 of B. So the dot just does things element by element. It's just like mapping it up and multiplying or dividing. Okay, does that answer about the dot, what that period does? Okay, so that's the period. I will save, we've already talked about publishing. That is 2.11, so I'm not going to go over 2.11 again, unless there's questions on Friday. That actually ends chapter 2. 2.10, if any of you have worked with DOS commands, of changing directories, of printing working directories, of listing, and things like that, Matlab 2.10, section 2.10 has to do with those kinds of file commands. Mostly you won't have to mess with it because you've got all this stuff over here. You can mess with files, drag and drop, and things like that. You've got a GUI. So mostly 2.10 you won't have to worry about. I'm going to stop here today. I will just, Friday, I'm planning just to talk a little bit about 2.10 briefly, and then dive into chapter 3 on Friday. Okay, and unless you guys have questions, we'll go ahead and end here today. Yes, Alex?
How do you create a vector going from like 0 to 5 pi fourths, going up by 1 pi fourth at time?
Okay, so theta equals your 0 is your starting point, colon, you're going by pi over 4, steps of pi over 4. Pi over 4 is your step size, and your end is 5 pi over 4. Oops.
Does it matter if you put parentheses or brackets?
Oh, yeah. Yeah, the brackets, the square brackets tell you to make a vector out of it. And the colon is, this is the starting number, step size here, separated by a colon. The colon separates it. So starting number, colon, step size, colon, ending number. There's also a function called linspace, which works a little different. Oh, well, here we go. Just create the vector. Colon. Oh, to suppress output. If you put a semicolon at the end, yes, it would suppress output. Okay. Linspace works as start, stop, number of steps. So the start would be 0, comma, stop would be 5 pi over 4, comma, linspace is a function. And then the number of steps, it looks like 1, 2, 3, 4, 5, 6. 6 steps. It should give us the same result. So you can create, there a lot of times in Matlab, there's more than one way to do the same thing. And this shows you that. Any other questions before I end? Okay, I'm going to stop talking. Grand total of about 5 minutes left in class. Take advantage.